So we're given a question here involving the area of a circle, and we're asked to find the diameter of the circle based on the area. So this first question really is practicing some algebra and manipulation of formulas. This question would be kind of a preview of what you would see in part 3 of the course when we actually deal with an entire booklet involving rearranging formulas and solving equations. So for this question, you would need to know the area of a circle. What's the area of a circle formula? Anybody know in the chat? I think we covered these last time. So there's two formulas for the area of a circle that we're probably familiar with, but the first one is this, pi r squared. I'll use a capital R here. Okay, oh yeah, we did circumference last time, that's true. So we're being asked here for the area this time. So I believe that the area of a circle, we may have talked about it briefly last time, but I'll just bring it up here again. The area of a circle is pi r squared. The question says to find the diameter. So there is another formula that you could use for the area of a circle. You could use area equals pi times diameter squared over 4. Either of those formulas is good. I'm going to use the one on the left because it doesn't have the fraction, and we can always find the diameter later. So that's my strategy here. So let's find the area of the circle using the first formula. So the area is given to us as 800. And now we have to solve for the radius. So we're going to solve for the radius, and then we'll solve for the diameter after. So if your algebra is a little bit rusty here, this will be a little bit of an exercise. But the first thing you want to do here is divide by both sides by pi. You need to get to the r. So we're going to divide both sides by pi. So, oops. So if we divide this side by pi and this side by pi, then the pi's over here will cancel. So if you do 800 divided by pi on your calculator, I did this just a second ago, you get 254.648. I'm putting extra decimals here just because I don't want to gamble that. Yeah, this will give you the radius eventually, James. Unfortunately, it's r squared. We have to take a square root right now. So I'm just going to write that down the other way. So if we take the square root, then we'll get the radius. And once we have the radius, I know that you can get the diameter without too much difficulty. So let's take the square root of that. And that's 15 and 0.29. 15.96 actually, sorry. Okay, let's just write that down. 15.96. The units in the question, just going to go back there. The units I think are in feet here. So that'll be in feet. And then you can get the diameter very fast. How do you find the diameter? Anybody in the chat there? How do you find the diameter? Thank you. So I'll just say here 2r and just I'm going to just do it on my calculator. I get 31.92 feet. So that's about it. A little bit of an algebra exercise just to get you started. These questions, at least the ones that we're covering today, if you're getting worried about them, these definitely would represent tougher questions on a test or an assignment. So I'll just give you another minute or so to take down some information, and then we'll move on to the next question. For those that are curious, if you want to solve it this way, essentially it amounts to the same process, except that you don't have to do this step at the end. However, the algebra in between gets a little bit more annoying. Also, it'd be fun to know what the formula would be if you wanted to solve for r immediately. So what is the radius if you're given the area of a circle? If we walk through the steps here, the steps involved taking a square root and dividing the area by pi. So there's the formula for the radius immediately. So if you know this formula here, then you can skip all of this algebra and just get the radius quickly. And on that note, if you wanted the diameter fast, since we know the diameter is 2 times the radius, we can just put a 2 and multiply this value, whatever that is, however scary it looks, and there's your formula for the diameter in terms of the radius. Sorry, in terms of the area. So there you have it. A little icebreaker today. Let's do another question. And again, for those that are getting a little bit worried here, I told you that I'm saving kind of the tougher questions for today. So here's another question that might be a little bit tougher for people. It's number 7. It's the last question in that group of questions. And then we'll take a step back and we'll go and do the one that I skipped. So anyway, just read the question and we'll start it in 30 seconds. Okay, so we have the situation here that this is a square, so that's a square. And then at the end we have a semicircle. And we know that the total area of this thing here is 1,000 square feet. And the objective is to find the length x. So we know that we could state the area for each of these figures first. Can someone tell me what is the area of the first figure? What is the area of the first figure? In terms of x, what shape is this figure? And then what area would that have? So that figure there is a square. So what is the area of that square if the length of the square is x? Any volunteers? Okay, if this square is x by x, thank you, Nicholas. So this is x squared because the length is x and the width is x, so it's x times x. Now the second figure is a circle. The circle, we have a formula for the area of a circle. I mentioned it on the previous page. I know that the area of a circle is pi r squared, but I also know that it's, I mentioned, pi times diameter squared over 4. Both of these formulas are good. I'm going to choose the second formula this time. And the reason that the second formula is in my opinion, the better choice is because the diameter is x. See this here? That's the diameter. The diameter of the circle is x. So this allows us to write a formula there. Yeah, you could also times it by a half as well. I'm just going to do it this way because I want to see x in the formula. So the circle for the area for the circle is pi x squared over 4. And I know that if I take this area here and I add this area here, which I'm trying to circle, that I get 1,000. So there you have it. We have kind of a visual setup for what the formula should be. And notice that the variable x appears, and we'll deal with that variable right now. So I'm just going to zoom it out a little bit if anybody's drawing pictures. And let's go through this together. So we start off by writing x squared plus pi x squared over 4 equals 1,000. I know that some of you are kind of worried when you see pi and things like that. But how about this? Pi and 4 are just numbers on your calculator. So just type pi divided by 4. I'll do the same. So pi divided by 4, sorry, I'm just trying to type it, is going to be a decimal, and I'll write that decimal in here. So I'm being very, very just patient with this process. So we have here like 1x squared. There's a 1 that's in front of this x squared. And over here, if you divide those, you get 0.7854. X squared is 1,000. And now you can add those together, and then pretty much it looks like the previous question. In terms of the algebra that you're doing, it's very similar in style to the previous question. X squared is going to equal 1,000 divided by that. And then you can square root that. I'll turn it into a decimal first. 560.099. And eventually you'll get a value of x of 23.67. Now, I'm looking at the answer. The answer doesn't say 23, so hopefully I didn't make a mistake here. But I don't know, I feel pretty good about this.
Sir,
Yes, what's up, Nicholas?
should you not have times it by a half? Since it's a semicircle?
Ah, yes, thank you. Thank you, Nicholas. That's the problem here. So I treated it like a circle. So let's fix that. Nicely done. So then this here will be, we'll just work it out backwards now. Thank you for that, Nicholas. Okay, that's a nice one. And that's the right answer. So sorry about that, everybody. I just need to correct that here. So the issue is that this is a semicircle, and I didn't divide the formula by 2. So Nicholas, thank you very much. So that's for a full circle, but we want a semicircle. So I'm going to multiply this by 2, a half, sorry. So that's what this half is for. So I'll just give everybody a minute or two to take that down. So who agrees with the answer now? Who's good with this? Who has the same answer? It's so quiet today. Thank you, James. Sorry, I was just dealing with a setting on Blackboard here. Something's glitchy on my side on Blackboard. Thank you, Bartek. Okay. Now, if anybody's getting nervous here, like with this algebra, there's not many tricks that I can really pull out on you. So, what's the worst that you could see? Circle, maybe a square, rectangle. In this case, semicircle. And don't worry, I know that I got mixed up for a second here too. But anyway, there's not many tricks to these questions, and you know nobody's perfect. So I appreciate the correction, Nicholas, and we can move on with our lives now and try a different question. Hopefully, I can redeem myself. So anyway, we're gonna go back and do the question here that I'm pointing at on the left. This one here. So this question doesn't have any numbers. I'll give you a minute to read it. It's a little bit more intricate. I'm just trying to zoom it nicely for you. Okay, just take a minute to read that, please. All right, so some of you might be working on this. I understand when I'm asking, if you're not responding, you're probably just jotting some numbers down and figuring it out. The first thing that I notice is there's no numbers, and that might scare a few people away from the question. So what you can do, this is an optional thing. You don't have to do this because it doesn't matter if this is 10 here or 1,000 or a million or whatever. This area ratio or this percentage will stay the same. So what I want to do, just to make sure everybody's cool with it, so that they can actually answer the question, is pick a number. I don't care what number we pick here for the length of the square. I'll just use the number 10. So if you're like, why am I choosing 10? It's completely arbitrary, okay? You could use 1. 1 is probably the best number to use, but I'm just going to use 10. And what I want you to think about is if these are 10, we can tell quickly what the area of the square is. That's like the easiest question ever. What's the area of the square? Without any delay, that's 100. I haven't put units here. This could be 10 feet. This could be 10 inches. This could be 10 meters. I don't care what the units are. I'm just going to say without a dimension there that the area is 100. The issue now is how to find the area of this shaded region. This is a pattern that will appear a lot in your next math course in one of the chapters. So might as well play with it a little bit here. This figure here, whoops, this figure here that I'm highlighting in red is a triangle, an isosceles triangle that cuts the figure in half. Can someone tell me what the area of the isosceles triangle is? I'm not going to use subscripts, I'll use just colors. What is the area of the red triangle? Let me know in the chat. Yeah, that's right. Thank you, hurry up. It's 50, yeah. It's half base times height, but because the square is 100, because this guy's 100, the little guy is only 50, it's half as much. One more thing, and then I think we can move on to answer the question. Now, this thing in green is part of a circle. Now, obviously I can't draw it really well because Blackboard is really sluggish when I draw. But what shape is that green figure? What shape is that green figure? Yeah, it's a quarter of a circle. So the area of the green region is going to be pi r squared, and this time I won't screw it up, don't worry. It's pi r squared divided by 4. It's a quarter of a circle. Now we know what the radius is. The radius is 10, because this radius, that's r, we've already decided on 10, or at least I decided to use 10. So if you put r equals 10 in here, you're going to get a number, and I'll do that right now on my calculator. So that's 100 times pi divided by 4. So that's 78.53. I'll just do 78.5. Actually, I'll keep the extra digits. All right, we're almost getting there. Now I'm going to do another area. Let's see how many colors I could use here. What's this area here? Any volunteers on that area? How would I find the area in blue? What would that area equal? Could I use any of the numbers above to find that area? That's right, Temirlan. Yes, you're going to subtract the two areas of the sector, or in other words, the quarter circle, if you prefer, and the triangle. So that's 28.53. Okay, we're good to go now. So I'm gonna do a little bit of typing at this point because it's too slow to write this. The total area of the square quarter circle to know what the white area is. Yeah, exactly. The good news is that the question only wants us to find the percentage taken up by the shaded region. So we don't have to go that far. But we want to find, I'll state it over here. This is exactly what we want to find, okay? We're trying to find the area of the shaded region divided by the area of the square. That's what the question is asking for, expressed as a percent. So let's see what happens here. The shaded region is going to be 2 times 28.53. The blue and the green. So the green region, Sheldon, is the entire quarter circle, And then the blue is just this. It's just it's half of the shaded part. The blue region is half of the shaded part. You're welcome. So we have everything we need now. 2 times 28.53 divided by 100. So that's 0.571. So that's equal to 0.571 or 57.1%. This question is pretty nasty. And if you notice, even though this question, if you look at the numbering, it's number 3, sorry. I started with questions 6 and 7 prior to doing number 3. So that says a lot about this question. In my opinion, I think this is the harder question. But why was the other question done? Why was it listed as question 7? Perhaps perhaps the author felt that the algebra stuff is more scary to people. Sometimes the geometry is more scary to people. So think about that. Take a moment on your own and think about whether the previous question, like this question here with all the algebra, was annoying, or was it this question here with the figures and the geometry? Which question got you? Which question was tougher for you? Let me know in the chat. Was it the algebra question or the geometry question? So this one here, Sheldon's saying this one here. So who thinks this one here was the worst of the two? Yeah. Huria, thank you. I'm glad to hear that, because like, in my opinion, when I was organizing which questions to teach, I wanted to do this one last because of that reason. I just had a gut feeling that more people didn't like this question. And hopefully people that didn't respond to my ask there felt the same way. Okay, so I'll just give you another 30 seconds to take down any information here. I will post this at the end of class on Blackboard, so if you don't want to draw all this stuff down and you just want to do something a bit more passive, that's fine. For those of you that are wondering, how would you answer this question without any numbers? So what I can do there, I can actually walk you through that, but I don't want you to get too too annoyed. So what I'll do is I'll do it at the bottom of the page. I think some people will appreciate to see this. So just for that particular audience, let's do that. So what I'm going to try to do is keep all the same symbols. I'm just going to put all these guys up here, tuck them away in the corner. And I'm going to put this up over here. And now I'll do it without numbers. So instead of the number 10, I'll use X. So that's my strategy, okay? Instead of using 10, I'll use X. So all of these things here with the different colors, I'm not going to try to color these right now. That'll waste too much time. I'm just going to say them with English, okay? So the area of the square is X squared. The area of the triangle is half X squared. The area of the quarter circle is pi X squared, or pi r squared, but it's a quarter of that. And then we have the goods now we can play. So the area of the shaded, sorry, the blue part. So I'll say here half area of shaded region is going to be the quarter circle minus the triangle. So if you're wondering where am I getting all these expressions from, I'm just recycling everything that I wrote earlier. So for example, I think I could put the symbol square here. I think if I use the letter square, No, it doesn't handle it. So sorry. No fancy symbols. And then I can finish off the question by doing this. I'll just write it over here. Sorry for the slowness. So this is not really easy to type today. For some reason, it's a lot more weird. Okay, so the area of the shaded region is going to be 2 times this. There's 2 of those. And then the area of the square is x squared. All of the x squareds cancel. All of the x squareds cancel. But if you're not comfortable with that, let me turn everything into decimals first so that you feel better about it. This will be 2. And I'm just going to grab my calculator, and you can obviously help me out with this too if you like. Pi divided by 4, so that's 0.7854. So you see how the x words cancel? And you get 0.571 or 57.1%. So hopefully that was something that felt good to see. I wasn't trying to scare anybody away. I'll just say one thing here. All of this stuff here that I'm writing, I'll put it in like red. Everything in red, don't worry about it, okay? If that scared you or confused you, that's okay. You can still get the answer correct based on the earlier work, but at least you see it this way as well, and you can make sense of it. I will post this on Blackboard later, so if you didn't copy this down, you can look for it on Blackboard later. We're going to move on now and talk about sectors and arc lengths. So on page 18, there's a very short lesson on arcs, on circular arcs. So here's a circular arc. So focus on the circular arc here. So a circular arc represents a percentage or a fraction of a circle. If you wanted to find the area of that, we talked about that last time. It's based on the proportion of how much of the angle is compared to 360. So if this angle here is like 100, or in this case, maybe it's like 70 or 80 degrees, you would divide 80 by 360, and that would tell you what fraction of the circle this area occupies. In this particular section, though, they're talking about the arc length, which is this thing here. But based on the same logic, you can say that that length of the arc will be a fraction of the circumference of the circle. What fraction? Well, it depends on what this angle is. So let's say this angle was 80 and a full revolution is 360. Then you would do 80 divided by 360, and that would be the fraction of the circle. So that would be how long this is. It'd be 83/60ths of a circle. Now, I'm just throwing numbers at you in my head, but maybe I can show you a formula. So here's the formula. So if you want the length of a circular arc, this formula appears here. And of course, you can also write it in terms of the diameter. So we talked about the area of a sector already, and we're just kind of focusing on arc length here. Oh my goodness, that was the worst line ever. There we go. So let's talk about practicing maybe just one question just to remind you or know how to use this properly. So anyway, I'm going to be using the formula on the left here. It's essentially the same thing. If you're wondering what's the difference is here we have 2r, and instead of 2r, here you have the diameter. So I'll just white that out. So on the other side, we have just the diameter instead of 2 times the radius. Let's take a look at just one question, nothing dangerous. Calculate the arc length of a circular arc that represents a 138-degree section of the outside edge of a circle, and they give you the diameter. So I'm going to just go for the radius because I like using the radius pretty much all the time. So anyway, so the radius, how much is the radius? Just in your head, anybody? What's the radius? Thank you. Wait. The radius, the diameter is 74. Oh shoot, yeah, you're way ahead of me, Huria. That's okay, that's good. You're keeping me on my toes today. I like that. Anyway, the radius here will be 37. So the arc length, we could use either formula. I'm just going to use the formula involving the radius because that's the one that I just like. I prefer using radius in questions because radius is a smaller unit and will lead to less difficulty with calculations, especially the formulas for areas. So in this case, the arc length, or L if you want, is going to equal theta, whatever the angle is, divided by 360 times 2 pi r. That's the formula. Now, for those of you that are like, can I see a picture? Absolutely. Let's take a look at a picture here. So we're talking about an angle that is 138 degrees. I hope that you would agree that's roughly 138 degrees. I'm not trying to be perfect here. And then this is the arc length. So this is part of a circle, so it's curved. This is not the scale. And we're just trying to find L here, just this length here. We also know that this is the radius here and here. And those radii are both 37 feet. So let me just put them in there. Just in case it doesn't appear on your screen, I'll scroll up a little bit. Okay, so we have all the information in hand. We can just plug in some stuff and finish the question now. So we have here theta divided by 360, so 138 divided by 360 times 2 pi 37. And you can just type it all in your calculator and let me know what you get as an answer. Anybody have an answer for that? I'll be checking it on my calculator as well. Anybody have an answer for that? Anybody get like 80 something? Okay, well, can someone confirm this answer? 89.12. Thank you, Nicholas. 89.12 feet. So anyway, I'm not looking to mesmerize you with some ridiculous diagram and just completely mess up your day on a test, for example, or an assignment. I'm just going to keep it down to basics, making sure that you understand the formulas and how to use them. What you've seen today really represents a broad, not a broad, I should say, what you've seen this week represents a broad level of question difficulty for length and area. We've seen questions that were super easy, like area of a square or perimeter of a circle, but then we've seen how you can twist those questions and incorporate algebra even in terms of what we covered today. In terms of your practice, there are questions that we did skip through the book, and those would be the ones I'd recommend that you try. One last thing here with this arc length is the question number 2 on the previous page involving the curved roadway. That's a nice question for you to try on your own, but I'll just tell you this, okay, just in terms of a test or an assignment, I don't like using too many compound questions, like questions that have lots and lots of steps, because I want to keep the scope of what I ask you very short, so that you don't monopolize all your energy on one question. So this question over here on page 19, it's a great question. I want you to just try it for your own interest and to build up your confidence. But this question probably is not something that I would ask you on a test. I would definitely break it down into something smaller, into a much more compact question, but still is a great question for you to try, and also gives you motivation on why you even care to know about arc length. Because arc length is actually essentially how roadways are measured, because not all roads are straight lines. So anyway, that's all I have for you today. Today we're going to finish a little bit early, but next time we're going to be talking, or next week we'll be talking about volumes.